Hello everybody, we are 5013X, team order 66, and this is our states robot explanation video. So, this robot got us to Worlds. We got to semifinals, then we got knocked out by 2 points in semifinals, but we still made it to Worlds, which is all that really counts. So, let's start by talking about the drivetrain a little bit. So, this is our drivetrain. It's 600 RPM motors. We've got 4 in here and then another 2 down up there technically on a PTO, which I'll talk about in a second. So we got 4 600 RPM drive motors on a 36 tooth gear to a 48 tooth gear, which is 450 RPM, which is what a lot of teams have been using. It seems to work great for us. We've got 2 traction wheels on both sides. And then we have, what are they called? Omni wheels on the bottoms, bottom and top. And that seems to be great because it gives us a central turning point. Now we have had a few issues with a bit of friction when we're turning, but for the most part, it's great. And having this many traction wheels stops us from getting pushed around. We haven't had any issues with getting pushed around. We've also got our pneumatics up here and our battery. Try to keep our center of gravity as low as possible. Same with our tank down here. And then moving on to our intake, we literally, you cannot get much simpler than this. It's just C-channel with a little ramp so we can flip up to push into the goal on a 600 RPM motor, rubber bands. We will be switching to flex wheels because we got caught a lot of times with these rubber bands and it was a bit of an issue. But one thing that's nice about this is that we have enough space up here where we can actually match load from the top, and we can either eject down like this if we want, but we noticed that if you just leave them up here, when teams try to steal it, because a lot of teams try to steal tri-balls, we realized that you can't actually get it out. So it's a great spot for just individual match loads, doing 1 by 1. And then, oh yeah, so we have these sleds here. We had them here and going across, but they broke a few times. We replaced them, but they kept breaking. So we're gonna have a lot for our next robot design. We're gonna structure that a lot better because they kept breaking and it was a big issue. So moving on to our wings, we have just horizontal wings, both sides, just like this. So we just used a piece of polycarb over it, zip tied down, and you can see that we just have little stoppers that angle it a bit, so that gives us enough to get them over the bar, which is very helpful when people are match loading a lot of tri-balls. And how we got this design on here is we started with just a clear polycarb, and then we cut out these vinyls, and we did them inverted, so they're like mirrored. Put them on the back, and then we spray painted over them. You can kind of see it. They're kind of starting to show there. And then we have another set of wings in the back, which are just vertical wings. So these wings we used for wind point in descoring from the match load zone. And also they don't like get pushed back like these ones. And another thing that we use these wings for, here, one second, move the robot. We use them in the alley here because they can flip out and clear the entire alley, which is very helpful, and we've never had issues like for leaving tri-balls in the alley. So those are very helpful. Okay, and then here, I'll talk about launcher next. So this is a very simple puncher. You cannot get much simpler than this. We just have 12 tooth cut down in there to a 60 tooth there, and it's just on like the big rubber bands. I forgot what, oh yeah, 60 number 64 rubber bands, and just launches just like that. We've got a traction pad up here, but that was only for more the front of it. We actually had pegs right here to hold it up that we removed because they were getting in our way in qualification matches. But that was for skills, and we only ever used this for skills. In our qualification matches and finals, we just bowled the whole time, use our intake, because we found that to be a lot more effective than launching. Okay, and then moving on, we got two motors here and here. So how these work is it's on, both of these gears are on this axle here, and it's on a piston around the front side over here. And the piston, when the piston moves, this whole assembly moves with it. So it'll move and it's very hard to do by hand, but it moves and it switches onto our drivetrain. So right now it's on drivetrain and it works with the drivetrain, so that's 6-motor drivetrain. But if we flip it over here, it's now on our hang. So we spin this, it spins that gear, which spins that gear. And originally we had it from that 12-tooth gear in there, straight to this 84-tooth gear. But we realized that the hang was too low on the robot, so it was like down here. It was like down there. So we added this 36-tooth gear in here just to raise it up a little bit, and that goes all the way across and connects to this side. So we got the same thing on both sides with that connecting it so that it never gets like off of each other. Drive forward, and then it pulls itself up. We haven't had any issues with it, except our semifinals match where we lost by 2 points because it was like angled like this somehow. I don't know how it did that, so it got to B tier instead of C tier. So that was our only issue. That was the only time we had an issue with it. And unlike most teams, a lot of teams have ratchets to keep this thing down. But for us, we just have a whole bunch of rubber bands in there. And also because this gear ratio is so high in here, like you have to spin really quickly to a really slow RPM. Just the sheer force to push the motor is too much and it can't pull itself back down. So I'll turn off the thing here and it still hangs just fine. So yeah, so that's our robot explanation video. We plan on changing it to a sub-6 robot, but still being able to hang, so we're gonna make some sort of compact mechanism for that. We still haven't fully designed it out yet, but we also want to switch to 600 RPM. We're gonna stay on 2.75 wheels, but we want to switch to 600 RPM because maneuvering the field quickly seems to be very important now that people are bowling a lot more and not doing any like launching. So that seems to be another idea we're gonna change. And yeah, so we'll see you guys at Worlds.